Adam, the first question, quantum risk. Should we be worried about it today?
Yeah, so I think just a quick summary around most people talk about the quantum risk. So the advent of quantum computers, which have already been proven in academic and a number of industry leading environments, but are not yet commercially viable at scale. And the fact that the advances in computational processing allow them to break common cryptography methods now by advancing the mathematics effectively to protect them. So effectively getting to the stage where in the future the current mathematical mechanisms used will be able to be broken in a matter of minutes, rather than whereas now it would be weeks and months. In fact, that means that anything that you're transmitting in the future, if you kept to those same protective mechanisms, we'd effectively be able to read in not quite near real time, but in very near time from you sending it. I think the other angle that people normally talk about is the fact that there are data collection points starting to appear around the internet, with copies of data being transmitted today and being stored with the view around they will store now and decrypted later. But the fact that anything traversing the internet today will be read at some point when it becomes viable to do so in a cost-effective manner. We've talked, I think, around the quantum computing landscape around the fact that that's probably a 5-year horizon for those to be broadly available, although competent and capable threat actors probably have access to those resources in a much nearer term. I think so. One of the kind of questions people around should they be concerned yet is, are you confident that any data you're transmitting across the internet will not still be scary or a thing that you're worried about in 5 years' time? That'd be true when it's 3 years' time, 2 years.
Yeah, I think there's a very big concern in our part about the quantum risk. We must remember that quantum computing itself is going to be a great thing for mankind, and so there's a big driver for mankind. And it's one of the great challenges of our time today, such as nuclear fusion and other great technologies that are emerging. But I think the timeline is something that there can be no risk taken on it, because one of the biggest concerns we have in the cybersecurity industry is about the so-called harvest now, decrypt later risk. And again, for people who are not aware of what that is, that's people I can encrypt my information, but if you take it now and put it in a box, and then you can decrypt it later using quantum technology, either in the near future or distant future, that could be harmful to me. And we only have to think about it might be emails, it might be IP, financial information, or anything. So the reality for that part is a concern now. And that's why I think it's a very real discussion that everyone should be having, not only in the industry, but also with government agencies.
Yeah, I agree. I think some of the really interesting underpins is things like Shor's algorithm that is used by a quantum computer is in the public domain. So anybody can apply that to these new technology, super fast computers they arrive. I think if you look in the public domain, you're seeing various state actors invest heavily in AI, machine learning and quantum. And whilst there's lots of debate over how soon it's coming, one thing is for sure, it is accelerating, whereas the protections against the threat of quantum computers, particularly as it applies to public key infrastructure that we generally rely on in many, many areas, is getting closer and closer. And a way to defeat that is getting harder and harder. So I think, as you underlook those things, it's coming. Should we be worried today? I obviously lean to the fact of yes, we should be worried today. And we talk about things like harvest now, decrypt later. So anybody with any form of long-term value data should be worried. You only need a quantum to break the key. You can then push it into classic compute in order to facilitate taking all of the keys across those things and taking that data. You only need the quantum to break the key in the first place. How soon it will break it, there's again lots of debate, but it will be promptly, whereas compared to today where it seems to take a long time, whether that's hours or minutes is yet to be seen. I think what it does do is start to call into question cryptography as it stands and how we protect things, and then the realization that the world is becoming more and more digital. Sensors, IoT, all these areas that have little protection or some protection today. And once they do arrive, the whole conversation of harvest now, decrypt later becomes very much academic, because also you worry about the value of data today and the ability to deny networks and conflict networks. So I appreciate there's lots of conversation around ransomware and all of these elements, which is really at the heart of, harvest now, decrypting the data or taking the data as it pertains to your networks.